The acceleration of a particle is a equal to 8 cos 2t I cap minus 4 sin 2t j cap plus 8t k cap, and you find the velocity and displacement of the particle using ordinary integral of vectors, and the given condition is at t equal to 0 displacement r is equal to 0, and at t equal to 0 velocity v equal to 0. We know acceleration a equal to rate of change of velocity derivative of v with respect to t. So acceleration is given by 8 cos 2t I cap minus 4 sin 2t j cap plus 8t k cap. So rate of change of velocity with respect to, or change of velocity with respect to time is equal to 8 cos 2t I cap minus b sin 2t j cap plus 8t k cap. I have told you how to find ordinary integral of a vector function. First you have to identify the vector function. So the vector function is this one. This one is the vector function 8 cos 2t I cap minus 4 sin 2t j cap plus 8t k cap. This is your vector function. So dv will be equal to this of dt, this vector function with dt. So you can find out dv. So if you integrate dv, and you have to integrate each component of the vector function. Okay, so when you integrate the each component of the vector function, then this will be integration of dv, then this side will be integration of I cap, integration of 8 cos 2t dt minus j cap, integration of 4 sin 2t dt minus k cap, integration of 8t dt. So you have to find out the integration of each component or each scalar component of the vector function by using standard integration formulas. So integration dv equal to v, and here 8 cos 2t dt, integration of cos 2t dt is equal to sin 2t divided by 2, and you have the constant 8, and also you have I cap minus 4 into integration of sin 2t dt is equal to minus cos 2t divided by 2 into j cap plus integration of t dt. 8 is constant, you can take it outside. Integration of t dt is t square by 2 k cap plus c. Because of it is a indefinite integral, you have to add a constant of integration c. So velocity vector will be equal to, if you calculate it, it will be 4 sin 2t I cap minus here minus plus, so 2 cos 2t j cap plus 2t square k cap plus c. Suppose this is equation number 1, and we will find out the value of the constant of integration c from the given conditions. The given condition is at t equal to 0, velocity equal to 0. So if you put velocity equal to 0 at t equal to 0, this component will be equal to 0, but this will be equal to, the j component will be equal, cos 0 equal to 1. So this will be equal to 2j. This k component, the k cap component will be equal to 0. So c will be equal to minus 2 j cap. If you take this to this side, this will be negative, so c will be equal to minus 2 j cap. So you put the value of c or constant of integration in equation 1, so that we will get the equation for velocity. So if you put the value of c equal to minus 2 j cap here, then velocity will be equal to 4 sin 2t I cap plus 2 cos 2t j cap plus 4t square k cap minus 2j cap, and this is your equation for the velocity. And suppose equation 2, this gives you the equation for velocity. Then how will find out the equation for displacement? we know velocity is the rate of change of displacement or derivative of displacement with respect to t. So this is the vector function, that is 4 sin 2t I cap 2 cos 2t j cap plus 4t square k cap minus 2j. This is your vector function. So dr will be equal to 4 sin 2t I cap plus 2 cos 2t j cap plus 4t square k cap minus 2j j cap dt, and integrating both the sides, integration of dr, you have to integrate individual components of the vector function. So integration of 4 sin 2t dt, similarly j cap integration of 2 cos 2t dt plus k cap integration of 4t square dt minus integration of 2 dt. You can either take j cap here and again find the integration, but I have done in the as I have shown you in equation 2. So integrating both the sides, integration of dr will be equal to r, then integration of sin 2t dt will be equal to minus cos 2t divided by 2, and you can take 4 outside into I cap plus integration of 2 cos 2t is integration of cos 2t dt is equal to sin 2t divided by 2. You have 2 here constant, minus integration of dt 2 dt j cap, I have taken it here. So 2t into j cap plus for this component k cap component, you have integration of 4t square dt, 4 is constant, integration of t square dt is tq divided by 3. So 4 tq divided by 3 into k cap plus c. Suppose this is equation 3, and here c is also constant of integration, and you can find out the value of the constant of integration from boundary condition. And the given boundary condition is just shown given in the question. The boundary condition is at t equal to 0, r equal to 0. So if you put the value of t equal to 0, this will be cos 0. So you have minus 2 I cap here. From this you can get minus 2 I cap, but at t equal to 0, r equal to 0, left hand side equal to 0. But this term will be equal to 0 at t equal to 0. This term will be also equal to 0. So plus c. So c will be equal to 2 I cap, because 0 minus 2 I cap plus c equal to plus c. So c will be equal to 2 I cap. So if you put the value of c here, that is 2 I cap, you can find out the equation for the displacement. So displacement equation r will be equal to 2. If you solve it, this will be equal to minus 2 cos 2t, and from here c which is equal to minus 2 I cap I have taken here. So if you taken common I cap, 2 minus 2 cos 2t plus from this you have sin 2t minus 2t j cap plus 4 by 3 tq into k cap. So this is your required equation for our vector function for the displacement. So we have found out the vector function for the velocity, and also we have found out the vector function for the displacement. So in this way you can calculate, or you can find out the vector functions of given acceleration. From acceleration you can calculate velocity, displacement, etc. by using ordinary integral method or ordinary integral of vectors. Thank you.